I suppose I'd like to start by paying tribute to the people who lost their lives here in the city, and to the people who are working so hard to recover and rebuild the city. And I'm very grateful for the invitation to speak this morning. And I do so, I have to say, with a lot of nervous trepidation, because I don't know your city, and I don't know what you've been through in your city, and I'm just learning. So this, for me, is an opportunity for me to learn, but I hope I can also share with you some of my experience of working in cities around the world for quite a few years now. I've tried as far as I can to make this presentation about Christchurch, and you can see from perhaps recognizing the street layout of the city in this opening slide that I've tried to bring with me some analysis of your city. But what I also hope I can do is, by showing other cities and buildings, bring some common lessons. This is a unique circumstance. What's happened in this city, thankfully, doesn't happen to other cities very often. And it is a unique circumstance for you. But at the same time, the recovery, the rebuild of the city happens in a context where other cities worldwide are going through parallel challenges. How do they accommodate their industries to the 21st century reality of global competition? How do we handle the relationship between the all-pervasive private car and that sense of place, of being a person in a city that is the history of cities? How do we relate the inside, air-conditioned inside of our buildings to the naturally conditioned outsides? These are challenges that, and how do we do so in a way which is carbon sensitive? These are challenges facing other cities worldwide. I'd like also to just say thank you to the city for hosting me, and to Align for organizing this event and looking after me while I'm here. So the title, Spatial Accessibility and Human Behaviour, are really the essence of space syntax's approach, which is to look at the way places are laid out as networks of space, as geometries, and I'm going to show you an inkling of the mathematics, even at this early hour of the morning, into the analysis of geometries, but thankfully not too much. I'm only an architect, so I'm not a mathematician. So I've been able to scratch the surface of the mathematics and find enough in there to build a practice around. And I'm certainly not going to labor the calculations more than necessary. But designing people for places, that subtitle in black, is really what it's all about. Because at the end of the day, cities are made for people. Yes, they're constructed, and we have to put the effort into building them, constructing them. But once they're built, they are used and occupied by people for a purpose. And I want to speak about the purpose of cities. Why do we have cities? Why don't we all just live in the countryside? We live in cities for particular reasons, and we need those reasons to be forefront in our minds as we go about the acts of constructing, planning, regulating, and so on. So let's get into it. The history of global urban development is not a happy one in many parts of the world. Traffic congestion cannot be the goal of advanced civilizations. Yet, this is what the traffic jam is, perhaps what is most emblematic of modern urban development globally. And it was not intended. This is my first point. Much of what we plan for in cities doesn't happen, and much of what does happen is unintended. And does anybody recognize this city? It could almost be any city. It happens to be Beijing. Nobody planned to spend hours a day in their car, getting unhealthy, losing the social contact with their family and their friends, losing time because they're not getting to the meeting when they were meant to. And yet this is what we have done with our cities when we've planned them in the 20th century. And I want to touch on 20th century influences on architects and planners. And the consequences of traffic jams and the consequences of low-density urban sprawl. And yes, I hear these names and phrases used to describe Christchurch and urbanism in New Zealand, but it's a global phenomenon, car-based, low-density urban sprawl. It creates decay in urban centres. The centre gets left behind because the city moves to its edge. And that word pollution is a catch-all, that third one there on the right, for the fact that many cities have grown with the car faster than their basic infrastructure has provided fresh water, waste treatment, power to keep pace with the car. And this is one city in one of the richest countries in the world, Saudi Arabia. So again, these problems are global, and they don't just afflict the poor nations, they afflict the rich ones as well, arguably more so. And the challenge of cities is unfortunately getting harder. These graphs here are global population forecasts by the United Nations for cities around the planet, or the population becoming greater to 9 billion, but becoming greater in cities to 7 billion. The urban population forecast by 2050, more of us living in cities. But it's the two graphs on the right which intrigue me. Of those 9 billion, 3 billion are forecast to live in informal urban populations, which is polite United Nations phraseology for slums. That's the forecast. And if you're not living in a slum, you're middle class. That's the last graph. The 4 billion are middle class people. You're either one or the other. You're poor or rich. Those middle class people have expectations. I think there are two principal expectations that are relevant. One is meat, because meat demands grain, and grain requires farm land, intensively farmed to provide it. That creates the deforestation, which will afflict the planet. And then the second is the motor car. Those rich people will expect private transportation, or they will expect mobility. If we're optimistic about it, they will expect mobility. So these are the challenges that face many of us in the room involved in the delivery of cities, whether it's here in Christchurch, whether it's across New Zealand, or whether it's globally. And they are shared by many others elsewhere. But what are we trying to do? Let's just put some of the negative aside for a moment and focus on the positive. Why do we live in cities? And for me, I find this word transaction to be really helpful. Cities are there and have always been there and will survive because we will always need transaction. The coming together of people in space, whether it's public or private space, to trade. And the nature of that trade is simultaneously social, economic, and cultural. It's mates having a beer around a table, but possibly also sharing a little business insight, and people walking past them, bumping into them, introductions being made, that serendipitous encounter where you're with someone you know, they bump into someone they know, they introduce you to that person, and suddenly you've got a new member of your social network. And that process is intense in cities. It happens more in the center of cities than it can happen anywhere else, by dint of geography, of geometry, of the fact that cities are more intense places for transaction, or at least they should be. That's what we should always have first and foremost in our minds. And in that sense, I like to describe cities as transaction machines. And like any machine, whether it's a typewriter or a motor car or whatever, a machine can be either more or less efficient depending upon how well oiled it is, whether the parts work, whether they fit well, whether they're looked after. So what I want to come on to next are what are the parts of this machine that we should be looking after and making sure work. And it's not just the roads. It is the roads, but it's more than the roads. And there's massive value in the city. And as Hugh alluded to, the economic reality of planning. It's massive. The economic responsibility of planners and designers and architects is massive. So what's been going on with the machinery of the city in the last 50 to 100 years? Well, I've tried to summarize it in this pair of images here, where on the left is the city as it was up until the end of the 19th century, the city of Paris, in this case, the Champs-Élysées, where you simultaneously have road movement, the horse-drawn carriages originally, now the cars, but also now of the bicycle and the pedestrian, and you have a landscape of trees, and you have buildings where the front doors of the buildings open up onto the street. This is not shocking. This is what cities always were. Streets with buildings fronting them, in which you could move quickly or slowly. Very banal in a sense, but magic at the same time, because in there was all life. And then the city on the right, which is back to my city in Saudi Arabia, actually. Now that road carries the same volume of traffic as the Champs-Élysées, but the buildings face away. There are no pedestrians. There's no pedestrians, not just because it's hot in this city, but because there's no shade. And also there's no purpose. There's no reason to walk on this main street on the right, because there's no street life, there's no cafes, there's no building entrances, no houses. Yet, and if you're driving on the road, actually, if you're driving quickly probably, and you can't turn off it because the road flies over the intersection. You can't turn off it easily if you're heading in the wrong direction. You have to drive a kilometre to the north, U-turn, and drive back. Yet this is what 20th century planning evolved to be. And this diagram of fast-moving traffic through cities has been the diagram that the professions have sold to the world. And from my own country, the UK, we've been leaders in this, and as have the Americans, selling this modernistic diagram. Yet the consequences are phenomenal and damaging and bad. The intention was good, but which was to give people access and mobility, but the consequences for American cities, which have once had historic cores ravaged by fast-moving cars, Cleveland here is just one example, are that people have flown to the edges of these cities, and the city centre, think about Detroit, is really suffering. Where did this all come from? Well, let's blame the Swiss or the French, or let's blame Le Corbusier for a moment. The idol of many architects of my generation and many current young architects, and many architects who went before me. And if you are reading that quote there, it's shocking. He was designing the city so that he could drive quickly through it, burn gasoline. I mean, it's blatant, it's obvious. There's no excuse. It was all about the car. And it wasn't just about the car, it was about the fast-moving car. And as a consequence, the buildings became islands separated from each other and connected by cars. This was the ideal. And this was what I was taught to deliver. And if we see the consequences of cities in Saudi Arabia as being highly negative, then it's been deliberately done by the professions who've earned fantastic fees from doing it. Yet it hasn't delivered those places of transaction. But let's not just blame the French and the Swiss. We can blame a few Americans and Brits and so on, because we can track the history back. The city has been turning in on itself, arguably, for the last 100 to 150 years. Clarence Perry's neighborhood plan, emanating in United States urban thinking, was very much about having fast roads on the outside and quiet, slow roads on the inside. And you create these neighborhoods separate from each other. And we took that to an extreme in the UK in our New Towns program. This is one town called Skelmersdale, where we added a new dimension, landscape, green. And we clad these fast-moving roads in green. And we put green between every little neighborhood parcel, and parks and paths and brooks and streams and glades, and call them what you like. They're lovely words. But their physical consequence has been as divisive as it's been connective, and arguably more divisive than connective. These green strips have kept people apart from each other. Now, I'm mentioning this clearly because the green frame for Christchurch is a landscape proposition, and I've been fascinated to hear about it. And I'm learning how it is very clearly intended to connect. And I have to say, the more I hear, the better I feel about it, because that's not what has come across in what I've been reading until I've got here. But let me just raise this as a subject right now, that green is good is the mantra of many an urban planner at the moment. I just want to raise the spectre of history, where this place, Skelmersdale, is a place you only live in if you're poor, because those who have had any money have moved out as quickly as possible to find place, to find community where they couldn't find it, where it was planned for them. Green was certainly not good for Skelmersdale. We haven't really blamed the architects enough, so let me just keep going. Because there's another, almost, I think perverse is the right word, phenomenon in architecture, which is that you pretend that it's urban, but it isn't. And so this is Barcelona, that great beacon of urbanism, of wonder. And much of Barcelona is, but that tends to be the older bits of Barcelona which are superb. This is a new piece, freshly built, around streets. But if you look really closely, those buildings have one entrance, and they all face inwards on that empty courtyard where there's no people there. And they front the street with blank, beautifully polished granite walls. And so you can drive past that development and never see a soul, and never see how to get into any buildings either. And yet this is what architects are quite comfortable doing. And it's wrong. And so many new buildings are going to be built here in your city. Are the architects wise enough to know that what they see in magazines is actually not what it's cracked up to be? So let's go back. And if we want to create places for people, then let's look at movement. Let's look at that kinetic that so fascinated Le Corbusier. But let's look at it from a different perspective. Let's start by looking at it from the perspective of the pedestrian. Because movement is, as it says here, the lifeblood of the city. If we don't have movement, we don't get people to come together to transact. But we need more than car movement. We need movement at every scale. Now, I was never taught about movement as an architect, and so I want to play a game to see whether you've been taught about movement. Well, I was, but I was taught the wrong things. I'll come to that in a moment. Let's imagine, okay, thought game. It's got to have gone, it's 8:20, so we're all wide enough awake to try this. We want to walk from A to B. How do we get there, given the choice? And if anybody wants to venture, I'd love a bit of audience participation. There's no prizes, there's no punishments, but how would we get from A to B? What would we be thinking about as our criteria? Shortest route, excellent. Shortest route is something like that. If you define shortest as metric distance. And it raises an interesting point, actually, that shortest can mean many things to a mathematician. And I'm just going to show you two. Because one is the path that is metrically the shortest. And it wiggles through like this. And actually, this is how many satellite navigation systems, GPS systems, calculate this. And your Google map will often tell you to take the shortest path. But you see what happens? You wiggle all the way through there. And every time you change direction, your brain has to make a calculation about what's around you, where am I going, am I still on the right path, and so on and so forth. So it's possible to think about shortest in another sense, which is actually not just shortest, but simplest. Simplest path is the one that involves the least angular deviation from A to B, which is effectively a 90-degree turn, another 90-ish degree turn, and you're there. About 180 degrees of turn. So if you measure distance by angle and not just by metric, you've got another way into it. And actually, if you asked a room of people, some will choose the first one or some will choose the second. What we've learned to do, as many others have done, is to study what actual people, real people in the real world do. by observing them. So there's a colleague of mine standing on the wobbly bridge in London and watching people cross it and making a map, and here's the kind of map that you can produce, which creates these beautiful traces where you start to see that there's a pattern forming. Not everybody, but most people follow certain routes. And this reveals an important aspect of human behavior, that we are pattern followers. I can't predict what any one of you will do individually, but I can predict what most of you will do most of the time. And I've learned to do that, and I'll show you how to do it in a moment, by following in the first instance. We do a lot of following of people. It's mostly still legal in the UK. And if it's legal in New Zealand, I recommend it to you all. And it doesn't. If it's illegal, then you don't have to stalk people, but just sit and have a cup of coffee and watch the world go round. And you'll learn more in 10 minutes watching the world of what people do and making a little map than you will in 10 days in a library. It's what I tell my students. I mean, spend time in the library, but spend time drinking coffee. And it's wonderful then to get a job where people pay you to do this. And make maps and visualize and make graphic these observations that you're recording. So here's an example of doing it. It's very, very simple. Send a team of people out there. We're doing this in Darwin. I'm going from here to Darwin in a few days. A team of people have been on streets counting people in the centre of Darwin. And the first thing we'll do is build a map like this. And we'll use colour so that the high flows are in a hotter colour, red, right down through the scale to the colder, quieter flows in blue. And this in itself, this isn't the clever bit. I'm coming on to the clever bit. But this in itself is hugely revealing. And you see how these patterns are consistent. They're not random. Human movement is very consistent. It varies during the day when people go to and from work and lunchtime, and the weekend is different to the weekday, but they're all following patterns. The same pattern is found week after week. You have market day and so on, but that in itself is a pattern. You do the same thing for vehicles. I know there's some transport people here. There's nothing more off-putting than a page of numbers. And yet, so many transport assessments are pages of numbers. If we can visualize those numbers as maps, my experience is the communities, the stakeholders who we talk to get their support for what we're proposing, much prefer to look at maps than numbers. Most of them. Some prefer the numbers, but most prefer the maps. Put your vehicle flows graphically, and this heat scale just seems to work. So let's get back to it. What do most people do most of the time? Some do the thing on the left, but most people, most of the time, follow the simplest path from A to B. And the cognitive scientists studying the human brain believe this is entirely because of the way that we're wired. The cognitive part of the brain is wired something like a grid, actually, in its anatomy, in which we understand right angles incredibly well. We understand the 90-degree turn very well. And that's why we get grids in cities. You know, the grid of Christchurch was an imposed grid, but it was repeating the grid form that has been in cities ever since we've had cities. From the earliest archaeology, cities are grids, rectilinear grids with right angular changes. It just seems people like that. So how can we study these grids a bit more? Well, here's another grid. It's not entirely right-angled, but most of those blocks are right-angled-ish. And what we've learned in my research colleagues at UCL have developed is a technique where we study the city, first of all, as a pattern of space, by colouring the space black and revealing the space as a network. But then moving to the next stage of saying, let's take that network and turn it into links. And we do this by drawing lines which are as long as possible, and we draw as few of them as possible to cover all of the network of the grid. And you see how they bend slightly, and some are longer, some are shorter. And then what we then do, this is the magic, is run an algorithm through them where we treat each intersection, each segment of space, each bit of street between two intersections, we treat that as the starting point of a journey. And we ask a computer, because it's really boring, you can do it by hand, but it's really boring. And there's a point where you you stop because you can only look at small systems. But you trace the least angle, the simplest angular route from that starting point to every other finishing point, every other segment of space in the city. And you do that for every segment. So these are thousands, tens of thousands, millions of computational events looking at each segment of space, each little bit of street, and all the possible journeys from it to everywhere else. And then the cleverness is to say, which are the streets that you tend to pass down most in all of those journeys? It's not just the origin and destination that matters, it's the streets you pass down. And when you ask a computer to calculate that, and then to take those streets which are traveled down most and make them red, and follow that same color code I showed you earlier for the observations, you generate this magic property called spatial accessibility, where that street going from left to right, snaking through there, is the street that picks up most journeys across the city. It's the backbone of the city, if you like. But I'm getting a bit ahead of myself, because what is it? Is this meaningful? Well, what we've discovered is it's hugely meaningful. If you compare those colors to actual flows of movement, so if you take two data sets, if you take the computer analysis of that spatial accessibility based on the geometry and smoothness of route, and if you take a survey from sending the team out, and if you correlate the two, we find time again consistent correlations between the amount of movement and the amount of spatial accessibility. The most connected streets get most movement, and the less well-connected streets get less movement. This is a one variable traffic model, one variable, which is spatial accessibility. And if you can just make out the little numbers at the top, predicting 60% of the pedestrian movement, 70% of the vehicle movement. And the transport modelers in here, I hope, will recognize that a one variable transport model with an R squared value of 0.6 or 0.7 is a pretty phenomenal event in the computation of urbanism. And it doesn't just stop there, because movement has consequences. Those consequences of transaction I mentioned earlier. Trade. If you look at where the shops end up in cities that grow organically, evolve, or are maybe even planned and then have a chance to evolve, we find time and again that the retail locates on the most spatially accessible streets, if you allow it to, if you don't over-regulate it, or if you regulate it in a knowing way. And this is London. All those red dots are shops. 80% of them are located on the top 20% most spatially accessible routes. Nobody, those shopkeepers didn't do a space syntax analysis. They went where the people were, and they went where their competitors were. And so you get this naturally self-reinforcing process that trade follows movement, and movement follows space. Now, the other people, the architects have been slow to pick this up, but the people who've picked it up really quickly are the criminals. The criminals understand space really well. This is an analysis from Western Australia, from Perth, part of the city, where we looked at the crime record. And it's possibly too small to see, but within those white circles I've drawn are little white dots. In fact, they're all over the page, but they're mostly located within those white circles, because those white circles are the least spatially accessible parts of the city, the most cut off, where the geometry of the grid is least well connected, and as a consequence you get less movement, less natural movement, if I can call it that, which means that if you want to break into a house, you've got the best chance of not being seen. And that's what the burglars do. They target the houses where nobody's going to see them kicking the door down and so on. And of course this is hugely important for police forces to understand, so that they can police where the targets are going to be toughest or easiest for the burglars. And every city's different. And I'm going to come on and show an analysis of Christchurch in a moment, but let me just show some uses of the technology for a few minutes. Here's Beijing with its unique ring structure. Because of the forbidden city in the middle of Beijing, everything has to go around the outside. I suppose in Christchurch you've had that condition while the centre of the city's been closed. Movements have to go around the outside and form a new dynamic. And how does business pick up on this? Where does it locate to be close to everywhere else and close to passing trade? Those are the sorts of questions that cities answer in different ways according to their unique geometries. Here's the geometry of Washington, D.C., where if you look at the hot spot, I find it helpful to squint or take my spectacles off to look at these images, because you see there's a nexus of red towards the top of the image. That's the commercial office retail center of Washington, D.C. The White House, the Congress, and so on are further down the image, more in the middle of it. Less well connected. They don't need to be well connected. People are coming to them anyway. The most connected streets are given over to the retail, the ones that naturally help people connect. So as a designer, you can take a tool like this, and this is really why I got into it, because as an architect, I was looking for a social dimension, and I came across a social dimension with a technical computational dimension, rigor and evidence, that I just thought was superb, because it allows you to say, well, here's a development site. What happens if you add some streets to it? Will they work? Will they glow red, or will they be blue? Will they be green? Where would you put the shops? On which street in that new grid would you put the shops? Where would you put the quiet uses, the housing, maybe the quiet little park? And in a very small matter of a few seconds or fractions of a second, you can process that and discover in this case that this grid of new streets is in fact highly spatially segregated within the city at large. This wouldn't work. This is a development that should never be built, because it won't be irrigated with enough movement to make it safe, to make it economically viable, and so on. So go back to the drawing board and try something different. Try perhaps a layout which builds from its surroundings, which teases streets into the site from the edges, which connects globally and locally at multiple scales. And process that, and you can achieve a quite radically different outcome in terms of space. And notice that, okay, we have a set of very strong red lines. We'd have high flows of movement through here. But we also have some quiet streets just off them, green and blue. This is the ideal of the urban neighborhood, that you have a mix, a range of streets, hot to cold, busy to quiet, just a turn of a corner away from each other. That's the magic of a city, where you can be on a main street, turn off it and be on a quiet street. You can achieve that if you get the geometry right. And then ask yourself, well, hold on, are people just going to come plowing through here in their private cars and maybe use this as a rat run, as a cut through? Well, then design it so they can't, so they have to drive more slowly. Give them fewer lanes, narrower lanes, put cycle paths in, pedestrian routes, landscape it well. Put all of the necessary detail of design in, but start with the strategic spatial design. That's really my point. Because if you don't, if you have one of those cold segregated grids, then no amount of love or money will make them work. You can't design them to work in their detail. Now, the more we look at this, and sorry, this is not really coming through very clearly, I don't think. The more we look at this, the more we realize there's power in space and there's value in space. And as Hugh mentioned at the beginning, the economics of space are fascinating to us and to our clients, the property developers and landowners and municipalities who are keen to make sure that land is valuable. And on this pair of images is effectively the same place in London, Earl's Court, massive development. And we made this analysis for the client to show that if they connected it on the left or disconnected it on the right, if they have the same number of buildings, same number of streets, same number of people, they would achieve vastly different economic outcomes, because they would have less movement on the right, more movement on the left. And with more movement and more connection become higher rents, is what we've discovered. So by looking at the rental base of London, we built a cash flow model that showed £335 million of difference between one architect's proposal on the left and another architect's proposal on the right. This is the power of a master plan. And a lot of money is being gained or lost unknowingly in the urban design field by not being able to pin down on the economics. These principles were behind the design of the London 2012 Olympic Park, the Queen Elizabeth Park, which is a park that has to work not only during the games, but afterwards. And that's why you see these teasing routes going in all directions, embedding that park into the neighbourhoods either side of it, that we were involved in the conceiving and connecting of. Or in Beijing, a new grid for a new kind of central business district in Beijing. If anybody's been to Beijing and been to the eastern Chaoyang CBD, it's a sterile place. There's very little life on the streets, and there's a recognition now among government that this isn't good enough. There needs to be a game-changing attitude to places in Chinese urbanism. And thank goodness it's happening, green and connected. But the earliest use of this technology, I think, on a wide scale was in Trafalgar Square in central London, where Trafalgar Square today, let me just flick forward, has this new staircase that brings people through the square. Trafalgar Square, principal public space in London. But previously, before Norman Foster, who led a design team we were part of, introduced this stair and closed the traffic off at the top of the square, it was in the top left image there, a place that in blue people walked around. They didn't walk through the square. Londoners, 99% of them, chose to walk around the outside of the square, not through the middle. In the middle, those little red dots were all the tourists. And we demonstrated this through that one image, top left. That was our competition submission. To say, at the competition stage, we don't have a design. We don't yet know, because it'd only be one of those crazy competitions where you've got a couple of weeks to answer all the world's problems through design. And we went in saying, well, we don't know what the design's going to be, but we know what the approach to the design is going to be, which is to focus on people, to observe them, and then top right, to model them and explain why they walk the way they walk, which is, it's the most convenient route around the square. So the red top right image, those red routes going around the edge are the shortest routes across Trafalgar Square. Most of the Londoners walking through Trafalgar Square just want convenience. And what that led us to say was, well, this is not really good enough. We want to bring them through the heart of the square, and in fact, that was our brief. So bottom left, in the forecast, there isn't a key on the computer that is the answer. You have to dream it up. The inspiration has to come from somewhere, from experience, from inspiration. We use these computer models to give us inspiration, and the inspiration was, well, the only way of getting people through the square is to create a staircase so that the red routes can crisscross through the middle. And we modeled that and showed how that would dramatically change the flows of Londoners through the square, and they would use the heart of the square for the first time, really, since the square was built. And that, if you like, psychological, cultural event of walking through the middle of the square rather than around its edges was a really powerful consequence that, upon delivery, was seen to actually happen. The staircase actually worked. I mean, thank goodness I wouldn't have a job if it hadn't, but it was a validation of, and there are members of the team in the room here today that we worked with on this, to deliver the square and make it a people place where people not only walked, but sat and stopped and transacted and made that place what it really needed to be, which was a place for people. So those sort of lessons have been taken to many different parts of the world since then. In Saudi Arabia, the problems of the city were addressing by trying to connect the slums outwards. So this is an image of a very, very simple three-dimensional image of a slum which the paler buildings are ones which are being transformed and the streets are being connected outwards so that the slum isn't spatially cut off from the wider city. Those streets are being shaded. I mentioned this image in a meeting yesterday. This was a sort of tear-jerking image for one client who thought it was a historic photograph of his city. He couldn't quite make it out. And we said, no, it's the future. It's a future of people walking under trees. And it evoked for him a memory of walking with his grandfather through the city that he could just about still remember, that had been gone in the last generation or so because of the car. This very, very evocative moment created by connections at all scales, not just local connections, but this is 5 or 6 kilometers worth of the city where we're connecting in a way which also catches the breeze that comes over the Red Sea from Africa, the cooling breeze, so that those left to right, east to west, west to east connections there are aligned with the slightly north of west wind that comes over the Red Sea, so we can irrigate the streets as well as connect the streets and make walking possible for people in the city. And it allows us to mark and evidence-base the analysis in a way where we can show that those red routes on the right, the healthy movement streets, the ones which are well connected, that we can then detune from being motorways into boulevards. Briefly, let me go inside buildings. I'm conscious of your time, but I do want to just go into buildings to say that when you follow, as we do, people in buildings and model them in a slightly different but related way based on connectivity and sight lines and so on, you can forecast the flow of people through galleries. In here, the Tate Gallery, where we've observed people on the right and then modeled on the left, and identified why the award-winning leading architect design extension on the right doesn't see the foot traffic that it was meant to, even though it's got the best paintings in Britain, the Turners, in there. The attraction can't overcome the spatial dislocation. So people walk in, turn on their heel, and walk out of the pictures, the rooms with the best pictures in Britain. It's sad, but it's the consequence of architecture. And the retailing world is very similar to the galleries world. I hesitate to say that because there may be people from the galleries world in the room who would be horrified to think of their gallery as a shopping centre, but they work spatially in very similar ways. This is Harrods department store, helping Harrods as if they needed it to make more money. A supermarket, helping the supermarket as if they needed it, get more people to pick milk off the shelf. More interesting, if you like, inside office buildings, places of innovation, places of new ideas generation, finding that the more accessible buildings, the people know each other more as a social network, and not only know each other more, but find each other more useful. That's a really, really important question to ask them. Not just how often do you see Fred, but do you find him useful? And if you can get an organization to answer that question, then you can help them understand how their space is sometimes helping and sometimes inhibiting their ability to transact with each other. And so we've used these lessons to design new buildings, laboratory buildings, art galleries, looking at different options for that same gallery before. University campuses, where the space of the campus, the public space, is part of the learning place for the campus. It's not just the classroom or hospital campuses as well, and right into the ward. Can the nursing staff see the patients? Can the patients see each other? Is the social as well as the functional atmosphere of the hospital being inhibited or helped by the spatial layout design? And there isn't time or perhaps even reason today to go into that any further, but it allows us to benchmark buildings. It allows us, sorry I'm moving quickly, I want to get us to Christchurch. It allows us to look at cycling, for example, a mode of transport which is becoming hugely important in London in recent years as well as in other cities, and is really part of the 21st century post-industrial replanning of the city. It's how I met Sam Martin, who's invited me here today over a project in London to radically change London's transport infrastructure through cycling. He'll say more about that later on, but we've been looking at how people cycle and where they cycle and finding the spatial rules, the way that they're influenced by other factors as well, their perceived safety, the infrastructure that's available for them, the character, whether they're cycling past active frontages or blank walls. So we're building models which then allow us to road test, if that's not a terrible use of the language, strategies, or propose routes and say that the best places to cycle are in red, that have the strongest characteristics, and so on and so forth as we travel through. So let me turn to Christchurch in closing. And I brought with me an analysis of the city that I want to share with you this morning, and I openly say we may have made some mistakes in it, and so please don't treat this as the kind of thought through, carefully articulated analysis that we would normally do. We've been doing this off a Google map, basically, or an open street map and some photographs and so on, and we'd obviously want to do it better, but I've been looking at the city as a plan and as a spatial network and the grid of the city and running the algorithm through it. So let me turn immediately to the spatial accessibility analysis of Christchurch, where we're looking here at a condition, I call it 2010. It was from historic mapping what we thought was the pattern of connectivity in the city pre-earthquakes. And I need to pause and distinguish the analysis at this point between global and local. What you're looking at on the screen here is an analysis of journeys through the grid from everywhere to everywhere else. It's imagining people can journey as far as they want. In a moment, we're going to turn to a different kind of analysis which restricts the journey length to about 1 kilometre, and it produces a different pattern which is much more about walkability and cycling. But at the moment, this is the kind of analysis that we would use to look at economic centrality. Where do local economic centres emerge that are dependent on vehicle access, vehicles moving long distances? And we can see how the grid of the city is prioritizing the radial connections that run to the north, to the southeast, to the west, and to the east. What I want to do immediately is move to the walkable analysis, because it's only once you overlay one on the other that you can bring out the overlapping scales of movement. And the overlapping scales of movement are important because those tend to be the places where shops emerge. Shops emerge to take advantage of local walking past them and global accessibility to them. Because a good shop is one that can capture a couple of markets at the same time, the local market and the global market. So let's look at this is like the walkability analysis, which is the local route hierarchy, where we look at the accessibility of each piece of street, in this case within 1.2 kilometres of it. You can vary the radius. We've chosen 1.2 because it seemed to us to pick out some centres around the edge of the city as well as in the heart of the city itself. So right in the middle, and I don't have a pointer to point, or the mouse isn't connected, but if you can make out in the middle of the city the strong red cluster of the city centre itself. But what also intrigues me are the strong red centres around the edge. And if I overlap one on top of the other, the global and the local, in this analysis here, red means a location which is locally and globally accessible. You can reach it in a car and you can walk a short distance to get there. And I was looking at this last night when I woke up, couldn't go back to sleep, and looking at the land use map and just standing in street view and looking on the streets and trying to identify if the centres to the south and to the west correspond with places of retailing, and in some cases they did, and that's what I would expect in the city. Certainly the city centre itself. And you see how you get a strong north-south pattern of red in the centre of the city. Is that meaningful? I don't know. High Street itself is blue, the diagonal in the middle. That means it's more locally important than globally important. That would seem to make sense. And then those green routes are ones which are more globally important than locally important. It takes me anyway a few seconds just to get my head around the colours here. And the question is, well, let's just say this corresponds to the way Christchurch was working before the earthquakes, that there was a dominant centre, but there were also sub-centres to the north, south, west and east. What happened after the earthquakes when the centre was no longer available? So as an experiment, we've taken out the centre of the model to look at what the natural spatial movement does in the city. And I'm going to flick backwards to 2010 and forwards to perhaps the condition of just a few months ago, when perhaps the city centre wasn't available in the same way that it in the last few days has become. And some of those local centres would seem to have already been there but are just being reinforced. But there's one centre, and I'm struggling to read it. Stanmore. I don't know. Stanmore Road. That has gained a lot of spatial connection. In this model, this is an experiment. The exclusion zone is just perhaps arbitrary because we didn't have time to get it accurately. My point being, even if Stanmore Road hasn't become important recently, it would seem to me that some streets will have become important, some places will have become important that were never important. Others will have become important, more important, but were already important. And when you then say, well, what happens when we put the city back together in the blueprint, which I'm going to come to next, how will that dynamic change again? And will there be places which have become recently important, which are no longer going to, spatially anyway, have that, because the flow can go back through the middle? So what we've attempted to do here is to put the city back together as we saw it in just a month ago, where some streets were open, but not everything was open. And again, we may have got this very wrong, but it's making the point that the computer can accommodate itself to different scenarios. So please don't read too much of the accuracy into it, but rather the point that this is a very quick and dynamic way of saying, well, what happens if we open this street or close that street? And if we turn to the blueprint and then say, how does the blueprint change any of this? Well, our analysis of the blueprint based on the diagram, and the diagram, I use the word deliberately because through conversation I understand how much this particular image is diagrammatic and not entirely specific in its detail. But we've analysed that as best we could. That's its global pattern of spatial accessibility. This is its local pattern of spatial accessibility. You can perhaps just pick out High Street as the diagonal in the centre of the city there. And then if we do the overlapping thing of saying what's globally important, what's locally important, my question was, well, how does that compare with 2010? Has anything changed? And I'm going to flick to 2010 in a moment just so that you can see that. But again, we're still seeing the strong north to south red network in the city centre. Those are the routes that are both locally and globally important. That's where I would expect shopping to do very well. And we still see the peripheral centres as being important. It isn't about just the centre or the edge, it's about the centre and the edge, if you like. So let me flick back to 2010. And then I'm going to go back to blueprint, 2010. And then back to blueprint. There's not a massive amount of change. And I wouldn't personally read too much into this based on knowing how rudimentary the modelling has been so far. But the point being that as you add more detail into the plan, you can add more accuracy into the analysis. I think I will close. Let me just make one last point about size. Size of city centre. It strikes me that the frame defines a very small city centre. And I'm interested to have this and understand more about the thinking behind this. And so coming here, I brought with me an analysis of other cities and the sizes of their CBDs, city centres. Now clearly, if the frame is connecting and not separating as a landscape, then the size as defined in the images you're going to see is less important. If any of that landscape is actually disconnecting, then there's a risk. There's a risk that the city centre is being constrained. So let me just this is we've measured some key dimensions of the frame and the blueprint, and then we've applied them to a range of cities. So I've overlaid over Auckland the size of the Christchurch city centre, and then we're going to go to Wellington next, and then, for what it's worth, to Perth. And then onwards to Adelaide, which in some ways is the conceptual forerunner, perhaps, of the frame in terms of its encircling green, but at a completely different scale. And of course, the population of Adelaide's much bigger than the population of Christchurch. Look, I don't want to say much more about that until I've learnt more from you. So let me just finish now by saying thank you for having me. Whatever happens next, my experience is if you can both base it on science and evidence and technology, if it's fundamentally based on the human, and that to me comes down to common sense, actually. Common sense being the naturally evolved experience of cities for not just decades but millennia, based on the human, then there's a much greater chance than if it's based on 20th century concepts of transport and land use zoning. But I'll leave it there and I'll be very happy to take some questions. Thank you very much.